All right, that'll work. I lost my pen. All right, guys, let's take a look. So you guys noticed, can I borrow, you guys have a Z-score chart right there? All right, guys, focus. Look down here on your Z-score chart. On the positive Z-score side, you see a little baby chart? 95% confidence is a 1.96 Z-score. Hey. But you know I'm not going to give you something that's one of these for at least one of the problems. But this first one, if you do the work, 95% confident, there's 0.025 out here. This is an area, of course. You get negative 1.96, don't give a shit about the negative because their plus and minus are both built in to the formula already. All you care about is the 1.96 part. The plus and minus is already built in. X bar, I tell you. Sigma, I tell you. And N, I tell you. And why is it okay to use Z-scores here? Why is it normal? N is 37, bigger than 30. Check. And now we can just do it. So that's the check for means. The sample size has to be greater than 30, or it has to just say it's normal already. Then it doesn't matter how big of a sample I take. So just plug and chug. What do you guys get for the error? Yeah, that sounds familiar.
69.21.
806.
Oh, yeah.
Yeah, so there's the error. That's how much I think I'm off by. So that would go from 596. 206. That'd be 206. Okay. Depending on how you rounded things. Alright, so that by itself is the interval we created. It's not the answer though. This is the answer down here. We are 95% confident that what? The interval 67.596 inches to 69.206 inches contains true mean height of men. Yes. Boring movie. City of Men. Height of Men. No? Okay. Blah, 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 blah. Now, this one I put up on the board, and of course I erased it. The derivation of this. It's just algebra. So if I know that this is the error, one of the most beautiful things about algebra, help me out. What is 10 divided by 2? Holy shit. What's 10 divided by 5? See how these can just switch places and it's still true? Of course, because if you divide 10 by one piece of it, it's the other piece. So I can just switch the places here. And then I square both sides and I get that formula. That's where the formula comes from. So you plug in what you know. I know the z-score, we already did that earlier. I know the sigma, still 2.5. Now if I put 0.806 down here and square it, I'm going to get n equal 37. I already know that 37 men leads to an error of 0.806. I'm not saying verify that. I'm saying I want it to now be within 0.5 instead. So divide by 0.5 squared. And what do you guys get? 96.04, and you always round up. You need 96.04 people. Any less than that, and you won't be within 0.5 inches. So you always just round up. A nice whole number of people. You don't want to lop off somebody's ear and say, I got 0.04 of this dude. Or I don't know you. Maybe you do. In which case, stay away from me. Alright, now. Is everybody cool so far? This is what I call a feasibility study. What does feasibility mean? Feasibility.
Like to check out something like feces or works in like the environment, or like if something's feasible, it's like
If something's
doable.
feasible, it's something that we're able to do.
Yeah. Able to.
So if N here came out to be 78,000 people and it's just me doing the study, that's not feasible. I can't expect to get within half an inch. But this is 96, 97. I mean, I can talk. In fact, how many people I've already talked to? 37. So if I said how many more men, it would be 97 minus 3. I need 60 more dudes. I'm like, that's feasible. I can do that. That's possible. If it was 800,000, I'm like, well, maybe I don't want to be within half an inch, then screw it. You guys semi with me? I'm not going to test you on the word feasible, but it's a good word to know. Okay. The second one is about the percentage stuff we just did. Does this formula make sense? What did X represent within binomial probabilities? The number of successes. Right? First you don't succeed, suck at second. So how many successes did we have? 316. Out of how many total people? 52. So you have 316 out of 652 is what? 4? 8? 4? 4, 8? 5? 4, 8, 5. So what's Q at? 5? 1, 5. Black gap. And N, of course, we know already was 652. Now, alright, let me talk about this. There was a sheet I gave you a while back. I don't know if I have any more of them. It was, we didn't even focus on the side that had the histogram in the middle about flipping coins. Do you have it? Thank you. Does that look normal? Yes, it's a very good answer because it totally looks normal. What was the mean in this case? Did anybody do this? The N was 14, and the probability of success, of course, is 50. How many heads do you expect if you flip a coin 14 times? You expect around 7. So the mean was 7. So right in the middle. So does it have room to go up and come back down? Yes. What if the N would have been 1? Let me not write all over your paper. If the N were, I mean not N, if the mean was 1, the mean was just 1, then the highest bar would be around 1, and then would it have room to go up and come back down? Not really. Does that look normal? It looks very skewed, right? So obviously, the mean has to be more in the middle, so it's got room to come up and go back down. You guys are with me? Because that 0 is a wall. It can't go below 0. So if the mean is too close to 0, it doesn't have room to be normal. So you need to pull that mean far enough, but then it can't hit the other wall either. There's another wall up here at 14. Because that's the most I could have if I flip a coin 14 times and I get 16 heads. I need to check what I just drank or something. Something happened, right? So I need to have it, so it has to be in the middle, sort of. So what happens there is the mean, NP, has to be at least 5. But then NQ is actually the thing that is the failures. It actually kind of governs this side. It has to be at least 5. If those are both true, then it's in the middle. There's room for it to go up and room for it to come back down. It's a really beautiful idea. So what do you check when you have means? If N is greater than 30. Or if it says it's normal. What do you check if you have percentages? if NP and NQ are bigger than or equal to 5. Now for a specific problem, do we have P? No, what do we have? P hat. So then I checked NP hat and NQ hat. Let me see if anybody can see how the answers are in the problem. If P hat is X divided by N, what is N times P hat?
X.
Freaking X. So I already know, it's 316. Is that at least 5? Yeah. And if I have 316 successes, 316 is at least 5. Check. How many failures do I have? What's NQ got to be? NQ hat's got to be the rest. Yeah, 336. Is that bigger than or equal to 5? Check. What does that mean? Normal enough. So just like when I have a mean problem, I have to check to see the sample size is bigger than 30. If I have a percentage problem, I have to check to see if these two things are at least 5. Same idea. Check for normality. If it wasn't normal, we can't do shit. So this is kind of important. Yes?
Just to repeat, so when it's a percentage, it has to be 0.5, and then when it's...
0.5.
Oh, sorry, I missed it. Can you just repeat the last part about the when it should be greater than 5?
Yeah. NP and NQ, with hats or not, depending on the situation, whatever we know, has to be at least 5.
And that's for everything?
Period.
Period, okay.
If I have a percentage problem and I'm trying to use z-scores with it, that has to be true. Because how can I use that z-score chart? I have to know it's normal. This is the check to make sure that a percentage problem is normal enough.
Okay.
Same way n greater than 30 means I have something normal enough. Yeah. How are we feeling about that? Is that all right? I'm hoping it makes... There's deeper math behind it, but basically they all kind of boil down to the whole get it in the middle and it's got room to go up and down. That really is good enough to understand why this makes sense. I love you guys. You're all like, well, it takes, shit. So what I want 91% confidence. So how much is outside then? Yeah, 0.045 on that side, right? So if I look up 0.045 and then sharp, what z-score did you guys get? Okay, so here's 0.045 right there, almost. There it is, it's closest. That's only 4 away, so negative 1.70, the negative doesn't really matter. Why not? Because it's in the freaking formula already, plus or minus. All you care about is the number. That's how many steps I got to go away. I go up and down that many steps. Maybe. Let me see if you guys are cool with this. I want this other z-score too. Why didn't I do this one? Because if I got that one, negative 1.7, that's got to be positive 1.7, right? Symmetric around the middle. But how would I get this one using the chart? What area is below that one? What area is below this? Total. 0.91 plus 0.045 is 0.955. Look that up. You're going to get 1.70, but just see it happen. 0.955. 1.70? Holy shit. All right. Just to make sure you guys understand, we only have to look at the negative one because of symmetry, but if I did look up the other one, it would be the same thing again. Okay. So now I plug and shut. 0.485, give or take. 1.7 times the square root. 45 times 0.515 divided by 652. Aw. So if I do the error, you get 0.033. Is that what you guys got?
Yes.
Yeah. 45, give or take, 0.033, so I get Write it somewhere. Where the hell am I going to write? 0.452 up to 0.518. Okay, so we are 91% confident. Oh, got it. That the interval 40, yeah, the 48, 40, where'd you go? There it is, 45.2 to 51.8% contains the true percentage of voters in Wisconsin. 11. Wisconsin that voted. Woo! Oh, you couldn't even see any of that. I should tell. 91% confident that that interval contains the true percentage of voters in Wisconsin that voted. So if somebody said, I think less than half voted, what would your analysis show? I think less than half voted. Is this evidence that less than half voted? No, it isn't. Could it have been more than half? Yeah, if it was evidence that less than half, then it should not go above 50% on the max side.
45.
Yes.
So, for this problem, like, how do we know we're confident? 91%.
Say what? Say what?
Because I don't get, because it's 45.2% to be 93%. How does that make us?
No. All right. So this kind of sucks. There's a percentage confident that I want to be about. It could be about the number of shoes that somebody wears or whatever. In this case, it happens to be about percentages. So you see how I want to be a certain percentage confident about where percentages are. So you get confused about the percentages. The level of confidence, what did it do with this problem? What did it have to do with this problem at all? The 91%, what did it do? It did one thing. Z-score. That's how we got it. If I wanted to be 92% confident, would the Z-score have been bigger or smaller? Don't even look it up, just tell me. Bigger. Think about it. If I want to be more confident that I caught something, do I go further out or not as far out? I go further out. I catch more shit. Z-score would have been bigger. Bless you. Did you guys get that? If I throw out a small net, I'm not very confident I caught a certain type of fish. If I throw a big-ass net out, then I'm more confident that I caught a certain type of fish. Exactly the same. I hate fish. I don't know what, but it just makes sense, the throwing the net out thing. Yes?
When you were saying about fish, like, if someone said that they were 50% sure it's not, because 51.8% isn't.
So now I'm saying, if somebody thought that less than half of Wisconsinites voted in the primary, does this back that up? No, because it includes the possibility that it's up here. If it was 48.5.2 to 49.3, that would be evidence that it's less than half. Not proof. You can't prove shit with a sample. But you can show evidence. Why can't I prove anything with a sample? Because every sample is going to be off from the real thing. But this leads to the idea of how to prove, show proof for something. So if I thought less than 60%, that would be proof of that. Not proof, but evidence. I got a difference. That would be evidence of that. Alright, now, this guy here, just to cut to the chase, if I take this error, the same way we did earlier, set this equal to E and solve for N, I will get this. Totally will. And you see when you square, these don't get squared too because they're in the square root, that's why they're not squared. So it kind of makes sense. So now, where does this go? And how do I put it in? Where does it go? Where does it go? For what letter does it go in for? E is how far I want to be off. I want to be within 2%. But what am I going to put in for E then? .02. I love it. Too many people on that last test. 13.2% thought this, so you used 13.2 in the analysis and you got these big ass numbers. Of course you did. 13.2% is what number? 0.132. You have to change it to a number before you work with it. Now on the top, we know all this stuff. We know Z, 1.7. We know P hat and Q hat, 0.485, 0.515. Throw all that stuff in the calculator. You did 1804? Is that right? You round it up to 1805. 805 people. You already talked to 652, so you need like 1,100 something. Oops. Again, when I had 652, what was my error? How far off was I? 3.3%. You guys see that? The error was 3.3%, 0.033. So to make it only 2%, I'm going to have to take a larger sample. That makes sense. To make my uncertainty less, I got to have a bigger sample. We've known that on day one. The bigger your sample, the more sure you are about everything from that sample. So this is the math catching up with our idea of what should happen. This is kind of beautiful. Yes? Do it again, sorry?
When you need to change the Z-score to find the
What I need to change the Z-score? What do you mean?
Yeah, well, since it's still in the answer.
Oh, no. That has nothing to do with the confidence level. That's how far off I want to be in my interval. I didn't say suddenly change the confidence from 91 to 98. So I'm still in the same problem. I'm still 91% confident. Again, the within 2% is related to the percentage of Wisconsinites who voted. 91% confidence only deals with how far out I go. That's it. I know they're both percentages, but they're both two different things. So the within 2% doesn't go back and change that confidence level. No. It says you got 3.3% there, right? So everybody cool with that? Everybody see that? When the N was 652, we were off by 3.3%. And now I'm saying, what do you do to make that become 0.02? That's what we did in the next part. How big of a sample do you need? I forget what the number was. 1,805. Yeah. Cool. So with a sample of 652, we were off by 3.3%. If we get a much bigger sample, 1,805, now we only think we're off by 2%. Which only makes sense, right? The bigger your sample, the less uncertain everything should be. Okay, maybe. All right, so here's the next thing. Can you bring the lights back? Thanks, man. Let me see if I can make this work.